Aloha, Richard Halverson here. This is ITS148. Today is April 7th, and let's see where we are. ITS148 and the syllabus. We're about here. That's right. We're going to talk about linked lists in this class, aren't we? Well, that's a real short chapter because in Python there is a list data type, and usually the section on linked lists in a second semester programming class involve how to create and manipulate lists that are linked together, one element at a time. And Python actually provides a data type that takes care of that for you. So it's actually a pretty short chapter. If this were a Java course, then we'd have to spend a lot of time on that. But anyway, so today I'd like to just go over, I finally came up with an assignment 3, which is about sorting, sorting algorithm and fast sorting algorithms. And it's a little bit simple, a little bit more simple than I was originally saying I was going to make it. And you'll see why, I think. Okay, so here's the program. Here's the assignment. And so today I'm going to go through this. So what I'd like you to do is implement the selection sort, the bubble sort, and the merge sort that are available in the textbook. I think this is wrong. Hold on a second. I just got to find it. I'll correct it when is this? Oh, here's all the. Okay, this is the sorting. Okay. All right. So I want you to create a new directory. Let's in fact, why don't I just start doing it? Richard H at ardh.its148.com. Nothing there because they aren't using the web part. cPanel. Boy, I got this headache about 3 days ago, and of course, whenever I get sick, I'm all paranoid. So I did one of those self-tests. I don't have COVID, but I got this weird headache that I've had this kind of headache before, but it's like it lasts around 3 days. I can't drink beer. It makes my head hurt, and just it's a terrible thing. So anyway, let's go to File Manager and go to Assignments, and so I haven't done Assignment 2 yet, huh? Let me see what Assignment 2 is real quick. I do have an Assignment 2. Oh yeah. Okay. Well, I tell you what, I'm going to do this sorting assignment first, and then I'm going to go back and look. And if I haven't done this yet, then I'll do this one next time. This is a pretty easy one. I made this one kind of easy. So I'm going to do a folder number 3, and then what am I supposed to do? Let's see. Put this here, and I'll take this out. Put it here. Can I? Oh, wrong one. Okay. So I'm supposed to make a 3, and then I made the 3, and then I got to make a I have to make a selection.py, and I have to make a bubble.py, and then I have to make a merge.py. And then I'm supposed to in selection.py copy the code shown in figure 16.2.1. So let's open up selection. And let's find, so if I go to Zybooks, this one, isn't it? Figure 16.2.1. 16.2.1. Okay. So I'm going to copy this over. Okay, so that's selection sort. And the way this works, I think I went over this before, but it helps to kind of understand it. You've got an outer loop and an inner loop, and you start by you start with a saying that you have one element, the first element in the list is use. Well, anyway, you say that that is sorted, and then you go to the next element in the list, which is this one here, and you go through all of the rest of the elements to find the smallest one. And then if that smallest one is smaller than the one you're looking at, which is this one in the first spot, then you exchange them, you swap them. And so now you have 2 elements that are sorted, and all the rest of them aren't. So then you take the third element, you're starting the third element, you go all the way down the line, find the smallest one, and then you check to see if that smallest one. So that's how this works, and you can go through it with an animation. I think you probably did that before. And then there's this swapping thing here, which is kind of important, except for we don't need to swap this way. We can swap using the Python swap function. You see this textbook was originally a Java textbook, and then they went through and they changed all the Java stuff to Python because it's the important sorting algorithms, computational complexity, searching, and then there's going to be trees and all that. Those are all standard data structures in programming and standard algorithms to manipulate those data structures. And then the language that's used that they happen to be teaching to manipulate those data structures. And so they had a couple of nice textbooks, and then they created Python versions. But what they didn't do is go through, and there's a bunch of stuff that's easier in Python than in Java, and they didn't bother going through and changing that stuff. So we can do that. We can say, instead of this, we say we're trying to exchange smallest with I, right? So we can just do number. Okay, I'm gonna comment this out. And you actually don't have to do this, but I like doing it because I like to stress the convenience and the advantages of Python, why things are easier. So we have numbers of I and numbers of smallest index, and we want to exchange them. So numbers of I, comma, numbers smallest index is equal to instead numbers of smallest index fix that, comma, numbers of I. Fix this. So, so what this is this one gets stored into this one, and this one gets stored into this one. So you see it's exchanging. And that's exactly what this does here, what this code here does. But it uses a temporary variable. Because in all the other languages, you need to have a temporary variable to do an exchange, except Python. All right, so so that's that. Now let's just run this to see if it works. It should work. And so what this does is this loads up an array, a list of numbers, and then it outputs the sorted version of them this way. And we don't have to do it that way. I guess we'll do it that way. And then we call the selection sort program, and then we output the list of numbers again. And the way this outputs a list of numbers is it outputs them one number at a time from beginning to end with spaces in between. So let's just see if this works. So I'm going to go back to the cPanel, main panel, and I'm going to open up the terminal, and I'm going to right click it to open it into a new tab. And I think I'll pop this out and kind of put it over here. This. And go back to here, and I'm just going to go to CD assignments, ls-l, and there's two assignments there, 1 and 3, CD3, and ls-l is there's my 3 programs, selection. So I'm going to run selection.py, and remember it's Python 3 space selection dot, I think I just do tab now, right? Yeah, .py, enter. And it doesn't like my exchanging. Smallest index is not defined. It's because it's not smallest index, it's index smallest. Idiots. Save, let's try it again. Upward arrow, enter. Okay, there. So here's an unsorted list, and after it's sorted, it looks like this. So the way this sorting works is it starts out and it says, okay, we're going to start out. We have one element here, and that one element is sorted, and now we got to start adding these elements. So this is sorted, and then it scans all the rest of them that aren't sorted to find the smallest one, and it's 2. So then it's going to exchange 2 with 10. So now we have 2, 10, and then we're going to scan here to find the smallest element, and that's going to be 4. And so 4 gets exchanged with the 10, and so on. And in the end, we end up with this. All right, so have we done the first? Let's see. Okay, so we've done. Then it says we have to do this. We want to indent the main part. Indent the main part of the program. In an if here. So I'm going to take this, copy, and I'm going to put it here, paste, and then I'm going to indent all this. And the reason is because I want to use this as a module, because I want to import this into a different program. I want to import this into a different program. I don't need any of this anymore. In fact, I don't need this either. Oop, didn't mean to do that. It's got to be at this level. So I'm going to delete this. Yeah, it's got to be at the same level as the 4. No, it doesn't. What am I doing? That's not right. Read backspace. That's right. Yes, it is right. Oh yes. Oh, I'm sorry. Yeah, this is the inner loop. So yes, that's right. Let me just get rid of all this. I was thinking it was the outer loop. Okay. So it goes all the way through, finds the smallest one, and then it does the exchange, and then it goes to the next one. All right, so I'm just going to confirm that this still works. And it does. Okay, so that's selection. Now let's go back here. And let's do the next one, which is bubble. This is where I think I got the wrong. I don't think that's right. I think it's. So let's open up bubble. Edit. And the problem with this one now is that it is not in Python. Now, one of the things you got to learn how to do in this class is to read an algorithm written in pseudocode, which is just a made-up language. It's a made-up language that's easy for people to understand, but it's not really a programming language where you can write, where you can run a program in it. But it describes a program, and that's what this bubble sort is here. So this explains bubble sort, but you notice it's very short, and it just gives you the algorithm. Okay, how does this algorithm work? Well, this is the name of the function. So in Python, you'd put a def in front of it, and these are the parameters. This is the array, and this is the size of the array. You wouldn't really need this in Python because when the array comes in, you can always just find the size by using the length function. But not all programming languages. With not all programming languages, you can do that because of different reasons. Okay, so then it's got this outer loop. And so this outer loop starts with the 0 with the first index, and it goes all the way up to the top -1. So if this is a 10 element list, that means its indexes are 0 through 9. The outer loop is gonna go from 0 to 8. Okay. And then the next loop here, the inner loop, goes from J starts at the 0th one. It starts at the 0th one, and it goes all the way up to the size of the array -i-1. Now, this is confusing for you until you realize that what's going on here is it starts at the beginning, and it bubbles the biggest one. When it finds an element in position J, which is bigger than position J+1, in other words, the next one down, then it exchanges them. And it keeps on going and keeps on exchanging these things until the very biggest one ends up down at the bottom. And then it starts again, and the next biggest one goes down to the bottom, but not all the way down to the bottom because the biggest one is down at the bottom. And it keeps on going until it goes all the way through. And I guess it does bubble. It does it actually does go through all the outer loop goes all the way from beginning to end, and the inner loop each time goes not from beginning to end, but from beginning all the way down to the first time it's down to the end, and then the second time it's down to the second to the end, the third one it's down to the third to the end, and because each time the biggest one is being bubbled all the way to the end, and so it keeps on doing that, even if everything is sorted in order. Now, a shortcut to bubble sort is when you do this inner loop, if you go all the way through and you never do a swap, you never do an exchange, then it must already be sorted. But we won't bother putting that in here. Maybe we will later after I get all of this running. We can see how much it improves. But anyway, what we have to do now is implement this bubble sort in Python. So let's try to do that. Let's see, where am I? I'm implementing it here. This is bubble sort. Okay, so and I'm going to make it like selection sort, because if we look here, it says convert the algorithm. Okay, where is that algorithm anyway? It's 6.3.1. Okay, this should be 6.3.1. 6.3.1. Save this. Okay, 6.3.1. So convert it into a Python function. So and then after that, we name it that, and then after that we add the main program from selection sort, except for we change selection to bubble. So I'll tell you what, I'm going to start with this whole thing here. I'm just going to copy this, and I'm going to go back over to my bubble, and I'm going to paste that there, and I'm going to change this to bubble. And I'm going to change this to bubble. All right, now, so what's left for us to do is to write this code as a bubble sort. And now, after a while, you should be able to do this, and you don't even understand at all what the algorithm does. You don't need to understand what the algorithm does. To convert this into a Python program, you just need to understand what the syntax means. Like what does it mean when you have a curly brace here and another curly brace here? You know, well, that is how most languages work, and how this pseudo language, this is actually well, actually a number of languages use this format, but Python indents, and all the other languages enclose the block. This is like the block underneath the bubble sort, right? So bubble sort is here, and then this is the block inside the bubble sort, and when the block inside the bubble sort is done, you're down here. This is the block inside the for loop, and this is the block inside the if statement. Now you notice that it's still indented. Well, guess what? The indentation does not matter at all. You don't need to indent. Okay, you can put everything all the way to the end. You can put everything all in a long line. It is the curly braces that define an inner block. This curly brace with this curly brace defines this inner block. In addition to that, when they're writing these programs, they indent. Why? Because it makes sense. It's easier to understand if they also indent. But the indenting is just, it doesn't, the compiler doesn't recognize the indentation. But in Python, you have to indent. If you don't indent, then it gets confused. Okay, it's kind of like leaving off the curly braces or something. But anyway, so knowing that, we should be able to just convert this to up here. And so we also need this number size thing. So I'm going to put that there. Number size. And then we go for I equals 0 to number size minus 1. This is number size. Oh, I guess we can just do number size. For I equals 0. So this is how it goes. 0, 1, 2, 3. This means increment I by 1 each time. So it starts out at 0, then 1, then 2, then 3, until it gets to while this is true. You keep on doing it while this is true. So this is I is number size minus 1 is that's exactly what this is. The number size minus 1. This is number size minus 1. And so this starts at 0. And yes, this is less than. So this starts at 0 and goes up to the length of the array minus 1 because it doesn't go all the way up to the top. It goes all the way up, but it doesn't include the top one. If you do for I in range of 5, then it's going to go 0, 1, 2, 3, 4. And so we're doing I in range of the length of the numbers, which is, if it's 10, that means it's 0 through 9, but then we're subtracting 1 again from it, so it's 0 through 8. And so that's what this is. So if the number size is 10, this says go from 0 all the way up to 9 because it has to be less than. It can't, if it's not equal to 10. While this is true, then you continue with the incrementing, and anyway, so this can be written just like that. So it turns out that the outer for loop of selection sort is the same as the outer for loop of bubble sort, but it's what's inside that's different. Here we just have another for loop, but we have another for loop here. So I'm going to take off this. I'm going to get rid of this stuff. I'll get rid of this. So this is the inner loop, J in range of J to number size. I'm just going to do range of starts at 0. So range of the length of the numbers minus I, but I don't have to do the minus 1. Yes, I do. Minus 1. Put spaces here. So this is I equals 0, I less than number size minus 1. This is J equals 0, J less than number size minus 1 minus I. With that's minus I minus 1 is the same as minus 1 minus I. So that's what this is. This is the I up to the range of numbers minus 1, j to the range of numbers minus 1 minus I, just like this, minus I minus 1. And this plus plus thing, that's taken care of in Python. Okay, and then this is if j is greater than j plus 1, if j is greater than j plus 1, is that right? Yeah, j plus 1, it's looking at the one just to the, looking at the next one, j plus 1, and that's why you go to, that's what this minus 1 is here. Anyway, if this is true, if it's true that the one next to it is smaller, then we have to change places because we're bubbling the big one down, the biggest one down. So here we have one that's bigger, and the next one is smaller. If in other words, this is true, so then it's got to switch places, and this switches the places. And this can be j plus 1. It's j and j plus 1 is what's exchanged. So j and j plus 1 is exchanged with j plus 1 and j. All right, this might work. So let's go to this, and I'm going to try to run Python 3 space bubble.py. Oops. py. And it looks like it worked. Oh, no, it didn't. What's the matter? Bubble sort is missing one required positional argument. Oh, all right. Comma len of numbers. How's that? That's the number size, the length of the numbers. The length of numbers. Now, there we go. Okay, so that's the bubble sort part. The merge sort part is harder. So let's go back to here, and open up merge. And we're supposed to copy 17.2.1. So let's go to 17.2.1. 17.2.1. And you should learn, okay, so I recommend that you learn, if there's only 2 sorts that you're ever going to learn, I would learn insertion sort, and there's a lab on insertion sort. The easiest sort is selection sort. So that's the easiest one. So if you want to memorize if you want to memorize a sort, selection sort is the easiest sort to memorize. And then, but these sorts are O of n squared. Bubble sort and insertion sort, the best case sort time is O of n, because if you give it a sorted, or if you give it a if you give it a list that's already sorted, then it just goes through takes one pass through all the way, down. There's nothing that triggers anything to be exchanged, and it's done. But worst case is O of n. If it's a completely if it's sorted in the opposite order, then it takes, O of n squared, which is a longer time. And I guess I talked about algorithmic analysis in chapter 15. But merge sort is O of n log n, which means as it grows, as the size of the array grows, the amount of time that it takes to do the merge sort does not grow as quickly. It grows by n times the log of n, whereas the slower sorts grow at n squared. So let's go to merge sort. Oh, we're here. And basically we want to copy, oh, and also merge sort is recursive. It's kind of interesting. So this is the merge sort, and what it does is it takes an array, and this is the starting position of the array, list. This is the starting position of the list, and this is the ending position of the list. So in the very beginning, this is going to be 0, and this is going to be the length of the list -1. But then it splits it in two. It finds the midpoint and splits it into 2 lists. You know, J is the middle. J's in the middle, and it starts out by, you know, if I is 0 and K is at the top, it's going to figure out what the middle is, and it calls that J. And so it splits it in half and does does a merge sort from I to J, and then a merge sort from J plus 1 to K. And so it keeps on calling this, keeps on dividing it in half and dividing it in half until you come down to the very bottom where each side has only one element. Okay, so if each side only has one element, then you have then each side is sorted, because if it only has one element, then it's sorted because it only has one element. So it keeps on dividing and dividing and dividing. This is recursive. It's recursion until it gets down to the bottom where it's being asked to, you have a list of 2 elements and you divide it in half, and so you have, you know, half of it is, you know, two lists of 1 element each. And then once you have 2 sorted lists, it's easy to merge 2 sorted lists into 1 sorted list, because you just start with the top one of each, and because they're both sorted. So you take the top one and you take the smallest one, and that's first, and then you look at the next pair, top and the 2 tops, and take the smallest one and you put it up there, take the smallest one, and maybe it's this one, and you keep on just taking the smallest one of the 2 lists, and you end up, you see that it's real easy to take 2 sorted lists and merge them into 1 sorted list. And so so here we're dividing in half, dividing in half, dividing in half, and then we're merging these lists all the way back up again. And so the dividing in half and dividing in half and dividing in half, that sounds like a log to the base 2 of n type of thing, like binary search. So it takes you know, log n to make your way all the way down to the bottom, where you have just a bunch of sorted, a bunch of single element lists, which by definition are sorted lists, and then you have to merge them back up again, and there you have to touch every element at least once. You have to touch every element once, so that's O of n elements. So you have n times log n, and that ends up being n log n algorithm. And so the purpose of this assignment is we implement these 3 sorts, and then we're going to start running. We're going to figure out how fast we're going to be able to compare the execution times. So for this one, we just need to take this whole thing here, copy, and paste it into here. This is merge. And again, we want to indent this. And put this thing here. So we have this list. We output the unsorted one. We output the sorted one. Are there any exchanges? There aren't really any exchanges here. Save changes. Let's go back to terminal, and now we can run merge. Python 3 merge.py. Yeah, is it the same list? Oh, it is. All right, so okay, so I think we've done the first part. And then I want you to write this program which will treat these three things that you just created. It treats them as modules where you can import this. So we're going to create another program here, and we're going to import I forgot to put the I think I'd like to give that to you also. I forgot. Where are my imports? I need to import. Ugh. I forgot this part. So I'm going to include this in this, so you have that also. All right, so we have to import random because we're going to create a random array. The way this is going to work is it's going to start out and it's going to ask the user, how big do you want your array? And so the user says, I want my array to be 10,000 random integers. So then it uses this random module, and here this will give you a random integer between 1 and whatever this is, a million or something, between 1 and a million. This will give you a random integer between 1 and a million, and it'll append it onto this original numbers list that we created here, original numbers. And so once this is done, original numbers contains this random list, and then we print it out if we want to. And then now the reason we create the random list and put it in this list called original numbers is because each time we compare a sort, we want to compare it on exactly the same array. So we don't want to generate a new random array and then do a sort and generate a new. So we want to generate the random array once and then use it on all three of the sorts. So this is for selection sort, and I want you to finish it up for bubble and merge, but it's just this calling bubble and merge. But so here we take our original numbers random array and we create a copy of it called numbers. And here I just put something in here where if the length of the numbers array is less than 100, then it'll print it out before and after. But if it's bigger than 100, it won't, because it'll be too big. So presumably you confirm that your program is working with lists less than 100, but once they get above 100, so if you want to compare 10,000, 50,000, 100,000, then you're able to do that easily, and you won't have the screen fill up with a bunch of numbers when you're running this. So so here we're supposed to create a new program called compare.py. So let's go over and do that. Create a new program called compare.py. And open it up. And I'm going to just take all this put it over here. And this is selection sort. So I tell you what, I'm going to run this for selection sort right now. This should work for selection sort. I don't think I need to do anything for this. And let's try to see what it looks like. Python 3 space compare.py. Oh, did we have that? Where? Oh, here it is. Selection module selection is not. Am I doing something wrong? Oh, what am I doing? Selection. Oh, I'm not supposed to put the py there. Let's do that. There. I'm not supposed to put the py. All right, array size, I'm going to say 10. And this is the unsorted array, and this is the sorted array. Does that look sorted? Looks pretty sorted to me. These are kind of big. Well, that's okay. So let's try. Okay, so this is how long it took. It took 3.8 times 10 to the minus 5th seconds. Well, let's do a bigger one. Let's do a 10,000. No, let's do a 1,000. Okay, that took 0.0768 seconds. What about 10,000? Oh, that took 3.24 seconds. Wow, that's longer. Okay, so let's fill this in for the other two. See what happens. I'm going to fill it in for one, and you can do this. You can do number two. Okay, I'm just giving it all to you. So let me copy this, and I'm going to do the one for I'm going to do the one for merge sort, because merge sort should be more interesting. So I'm going to do the one for merge sort, and you can do the one for bubble sort. All right, this. Merge sort. Merge. And it's got different parameters, doesn't it? Merge sort. Numbers, I got to put that in there. Yeah, all right, I got to put that in. There. So let's save this. Oh, it's got to be merge. So this is something that you should really learn how to do, because you know, it's just so there's this time module, and this will give you the time in, I don't know, perf counter. I don't know what that stands for, but it's going to be like milliseconds or some really small increment. And so this grabs the time and saves it into a variable called start. And then we execute the merge sort. And then this right away grabs the time and saves it into end, variable called end. And then execution time is end minus start. And then this just prints it out. Okay, so now we've got selection and merge. So now we should be able to see some nice comparisons. So let's start with array size of 5,000. So selection sort is 0.8 seconds, merge sort is 0.2 seconds. I'm going to do something smaller. I'm going to do 100. So selection sort is 0.001, merge sort is 0.0. Wow, that's I'm going to find out when they're about equal. So I'm going to try 10. merge sort is 7.7 times 10 to the minus fifth, and selection sort is 3 times 10 to the minus fifth. So select, if it's only 10 elements, selection sort is faster. It's more than twice as fast. This is half the time of this. So 10, if it's really small, use selection sort. But if it's big, let's look at 5,000. Oops. I do 5,000. I did 5,000. So let's do 10,000. Yeah, it's really now becoming apparent. If we do one more time, let's do. Let's see. If 10,000 took 3.8 seconds. If I go from 10,000 to 20,000, it's O of n squared, so it should be 4 times. It should take 4 times as long. So if I go from 10,000 to 20,000, it should take 4 times as long. If I go from 10,000 to 20,000, it should be like 1 times the square root of 2 or something, 1.4 times or something. Let's test our theory here. So I'm going to do 20,000. Four times 3 is 12, so it might take 12 seconds. Okay, 12 seconds. So 12 seconds for the selection sort, which is 4 times. And from 0.05 to 0.11 is about, I don't know, it's not 4 times. It's like 1.4 times or something. Well, I guess it's more like 2 times. Well, anyway, finish bubble sort, and that's really all you need to do. And I will get the auto grader thing up and running for this, in the next couple weeks. All right. Are there any questions?
No, not really. I'll just look over the video again.
Yeah, okay. Yeah, that's the idea. Very good. Okay, so I will see you next week.
Oh, okay, thank you.
Hey, thanks. Thanks for
All
coming.
right. Bye.